Hello everyone, welcome back to my YouTube channel, General Technology Knowledge. Today I would like to show and share about how to scale the analog output of PLC S7-300 by using TIA Portal version 16. Okay, so in this case I will use the current loop source 4 to 20 mA and multimeter that can measure the milliamp from the analog output. Okay, and in this case also I will use the same as the CPU in the previous video, CPU 314C2PN/DP that has built in the analog input and output module on the CPU. Okay, and I will use the LAN cable connect from the PLC to my PC by PROFIBUS port. Okay, so in the previous video we already learned about how to scale the analog input with the TIA portal, and we also tested with the real PLC also. Okay, and we include for test with the HMI simulation with the block. Yes, and for this section we will continue to analog output scaling and also simulation with the HMI. Okay, so let's go. But before go to the software TIA portal, I would like to share a little bit about how to wiring the analog output for channel of the module. Okay, so I will show. So here is the drawing, the existing drawing that we already learned in the previous video about how to connect the analog input. Yeah, totally there are 5 channels of analog input. That 1 channel, 2 channel, 3 channel, and 4 channel we can select with the volt and current. And for the last channel, channel number 5, we can select only PT100. Okay. And in this section, we will continue with the analog output. There are 2 channels of analog output in this module. The first one, we can connect the COM, it means that the minus, if we connect with milliamp or volt. So we can connect the terminal number 20 for minus, and for terminal number 16 it is the volt. If we select volt, we can measure the volt on terminal 20 and terminal 16. So if we would like to use the current, we can use with the terminal 20, it is the minus, and terminal 17, it is the plus or positive of the current. Okay, and for channel number 2 of analog output, we can use number 20 for COM, it means that minus, and number 18, it is the volt output, and number 19, it is the current output. Okay, then we can test with the software. Okay, so this just example about how to wiring, because we need to know about how to wiring before we can test with the software. Yes, otherwise we cannot test if we cannot wiring. So the wiring is very important for test with the real PLC and software. Okay, so right now let's go to TIA portal and then open the existing project that we already learned in the previous video. So let's open. We will see the existing project that we already learned in the previous video about how to scaling the analog input. Okay, so let's open the existing project. Yes, click open and wait a moment for open the project of TIA Portal. Then we can test with the example that we can create the function or scaling, or we can test directly with the analog. Okay, go to project view. Okay, and then go to the hardware configuration. Okay, first we need to know about the hardware selection. Yes, the same as the analog input. Yes, because we have two functions for analog output. The first one is current. Let me open and explain step by step. So here is the input we already learned in the previous video, right? The measurement type is current or volt that we can select, yes, or we can deactivate. It means that we can disable for each channel. Okay. For analog output, it is the same. Yeah, we have two functions that we can select, two options. The first one is voltage. If we select voltage, we can measure from 0 to 10 volt or plus minus 10 volt. Yeah. If we select deactivate, it means that we close the channel number 1. Yes, here output 0. So right now I will select current and then choose from 4 to 20 milliamp. Yes. Okay. And for channel number 2, I also select from okay, I will test with 0 to 20 milliamp. Yes. So channel number 1, 4 to 20 milliamp, and channel number 2 is 0 to 20 milliamp. And then we will test together step by step. Yes. So let me save the project and then download the hardware configuration to the PLC. Okay, so download. Actually, we can check the communication between PLC with the PC by using the command ping 192.168.0.1. Yes, it is the default IP address of PLC S7-300 CPU 314C2PN/DP that I already showed in the previous video about how to connect. Okay, so if we can ping like this, it means that the communication between our computer and PLC is connect properly. Okay, if we cannot ping, we can go to put the manual of our computer here. Yes, right now I put the manual already. Yes, here example 192.168.0.253, and for subnet mask is 255.255.255.0. Yes, and don't forget close or disable the Windows firewall. Yeah, by go to control panel and then go to Windows firewall, and then we can close or we can disable the Windows firewall for temporary. Okay, so right now we can ping, then we can download. Yeah, I will stop all. Yeah, it means that stop the CPU during we download. Yes, I will load. It means that we can download this hardware configuration to the CPU. Yes, and then click finish to restart the CPU back. Yes. Okay, so can start, and then we can test with the channel, yes, that we already select. So please remember, the first one we already select to the current, right, for analog output. So default is 4 to 20 milliamp for channel number 1. So right now the multimeter is show 4 milliamp. Let me show the status before we test, because we already set the setting for 20 milliamp, right? So default, if we download finish, the condition will change to 4. Okay, let's see here, the condition is changed to 4 for channel number 1, because I already connected the cable. Here is common, it means that plus, and here is minus. Okay, so default is 4 milliamp. So we can test with another option that we want. Example, we can create the block for move the signal, move the value to the analog output, by address here. So the output will start from PQW 800, 800 until 803, right? So let's go to our block. The existing main block, for analog input that we already learned in the previous video. So we can continue to write. It is the last video that we already learned, here for analog input. So example here, we can command test, only test first, because I will create the function, for set the value. Example, set 0 to 100%, it will generate 4 to 20 milliamp, because it is the basic. If we have the basic, we can create another block that we want. Okay, so example, test analog channel 1 of PLC S7-300 CPU 314C 2PN/DP. Okay, so channel number 1, we can use the function. Okay, we can use the function move. So we can click here. Okay, so we can move, use move. Okay, example, I would like to move MW to example MW 400. Yes, MW 400. We can use the take for move to PQW 800, right? It is the address of valid rank. I will move IW or MW 15. This one we can test, so we no need to put any command. Yes, we can test. It is the channel number 1, right? So if we would like to test channel number 2, we can move. Function move. Example, MW 16 move to PQW 82, right? Sorry, 802. it is the channel number 2, right? And then we can download and then test together. Okay, we can load and then we can online. Okay, wait a moment for online. MW16, or maybe this one duplicate with other one, right? Let me check. MW100, it is the word, right? Maybe I will change this one a little bit for channel number 2. So I will delete first and then MW17, sorry, 70, and then we can download again. Then we can online again. Can write or not? Which are decimal, right? So we can test the channel number 1 first. So right now it show 4 milliamp because the PQW is 0, right? That we show the status. Okay, so 4 milliamp. So if we write any number, example 1600, let's see, around 13 milliamp, yes. And for the maximum value is 27648, right? Okay, it is the 20 milliamp, so it works properly for channel number 1. So we can also test channel number 2. Yes, I will reverse the power, sorry, the cable to channel number 2. So for channel number 2, we can connect the 20 and 19, right, for channel number 2. Then maybe I will move this one to be like this. Okay, I will cut this one to here for channel number 2. Okay, save the project and let's try to download again. Okay, and then we can online again. Yes, online again to check it should be work, right? MW15, which are decimal, so we can view as decimal. Okay, and we can write 0. 100. Okay, we can view as decimal. Let me offline and then check again. We can view as decimal, yeah, for easy to understand. Decimal. Okay, we can online. And then we can test with channel number 2, right? Okay, let me reverse the power to channel number 2. So terminal 19 and 20. So let me copy from here for test. MW15. I will put the same as the channel number 1, yeah, for test. Then we can download. Okay. So right now the milliamp is show 20 milliamp or so. So let me write the value to 0. Okay. Write value to 0. It will 0 milliamp, right? Because the setting that we already set is 0 to 20 milliamp, right? Let's go to hardware configuration. And then go to property. Check here. The setting that we set is 0 to 20 milliamp, right? So example, I write the value 600. Yes, it will show around 12 milliamp. Yeah, it is the maximum divided by 2, right? Okay, so if I set the maximum to 7648, it is the maximum value. So it will show 20 milliamp. Okay, so channel number 2 is also work properly. Yes. So for analog output, it work correctly. So the next step, we need to convert to set point. Example here, example. Example, we would like to set from 0 to 100%, and it is the value. The example 0%, it will show 0 for raw data, and the value will show 0, and the milliamp will show 4 or 0 milliamp on the multimeter, right? So if we set 100%, yeah, 100%, it will output is 100%, and for the value is 27648. It is the maximum of value, and current will show 20 milliamp. Okay, so we will create the function for this formula. Then we can convert from percent to milliamp. Okay, so we can create the function, follow this formula. Yes, so let's go offline first. And then let's go to create the blocks. I will use function block. Actually, we can use a function or function block that we want. Yes. Now I will use function and the ladder. Yes. I will choose the ladder for language. And for the block, I will choose FC1. Yeah, automatically for FC1. Okay, we will got like this. We have input, output, input and output together, and we have temp, we have constant, and also have return. Okay, so the parameter that we would like to write, we have output and input, right? Low scale and high scale. Okay, so we can copy this one. I will copy the text to command. Easy to create. Follow this step. Yes. So the formula is the maximum of raw value of analog output multiplied by input minus low scale, right? And then divide with the high scale minus low scale. Okay. So the parameter that we would like to declare, we have input, output, low scale and high scale, right? So for input, the first one we have input value. Okay, and it is the real, right? Data type is real. Another one is the low scale, right? So we can write low scale. It is the real also. And one more, it is the high scale, right? So high scale, real also. Another one, it is the output, right? That we would like to generate from percent to milliamp. Yeah, here we key input is percent, right? Like 10.0 or 10.5. Yeah, it is the real. Okay, and it will generate the integer. Yes, so we can put output value. Okay, it is the real also. Then we can convert later. Okay, if we have like this, we can create the function. Yeah, so the first one is input minus low scale, right? So we can use divide, sub between input. Yes, input. So we can drag and drop here input value, right? Input value here, and then subtract with the low scale, right? So low scale here. Okay, and then we can create the temp, temporary variables. So example, I can use value 1, or we can use temp 1. It is the real. Yes, the data is real. So we can drag and drop. Drag and drop the value 1 here. Yes, to here. And then the value will divide by, multiply by maximum of the raw value of analog output, right? So we can use maybe we can use the multiply, yes, or we can divide this one and this one first, yeah. So we can use divide. So the first one is subtract also. So subtract between high scale and low scale. So let's go to high scale. Minus low scale, right? Okay, and this one I will create one more for value 2. It is the real also, and we can drag and drop to the output of this one. Okay, and then we can divide this one and this one, right? So divide between value 1 and value 2. So value 1 divide by value 2, and I will create one more for value 3. It is the real also. And then we can okay, I will connect here for network 2. Then we can multiply by the maximum of the analog output, right? So multiply between the maximum is 27648.0 because it is the real, right? Multiply real, yes, multiply by value 3. Okay, sorry, we can drag and drop from here. Yes, here. And then here is the output, right? So output, go to the output value, drag and drop here. Okay, and then we can save our function. And if we would like to use this function, we can go to this one. I will delete first because we not use. We just test the channel of analog only. Yes. So this one, use function 1, UFC1 for convert from percent to milliamp. From 0 to 100%, and the scale is 4 to 20 milliamp, right? Okay, that we can call the function to use. Okay, so let's save the project first. So this block I will use call the function to use. So we will got like this. The first one is input, right? Input value. So we can put any address that we want. It is the real. Example, MD. We use MD20, right? The last video, MD20. So example MD24, and the low scale. Sorry, the low scale 100. Sorry, 0.0, and this one 100.0, right? And it is the output, but the output is the real, right? So we need convert to the integer. Yeah. So here we can use MD20H. Use already, right? Not yet. Okay. 20H. And then we will move MD20H to PQW 800, right, for channel number 1. Let's see here, the data type is incorrect, right? So let's see here, the red color. So we need to convert first before we move like this. So I will use one more function we call func. We can convert from real to double integer, right? So example MD20H, and then this one we can use temporary variable. So I will insert the row here. Okay, example temp1. It is the double integer, right? DINT. So we can drag and drop here, and then drag and drop here. Okay, and then let's see again. So the color is normal color, so it's not error. So we can save the project and then compile the project. Oh, we have some error, right? Error 1. Let's see what is the error. Compile error. Let's check what is the error. Block underscore 1 is error, right? Compile again. Network 3 is error. So let's check again. This one to this one, convert from real to double integer. Okay, then this one is real, right? FC1. Okay, Okay, so first we can go here and then compile the FC1 first. Yeah. Okay, compile. Yes, successful. And then let's go to main block again, and then we will compile again. Okay, no error occur, so we can save the project and then download to the PLC, right? In this case, I will stop consider to download. Yes. And then we can online for test. So the scaling from 0 to 100%, right? So if I put 50%, yes, it will generate like this. Yes. And this one is channel number 1, right? So I will switch the cable from channel number 1 to, sorry, channel number 2 to channel number 1 again. So the terminal should be 17, right? I will put 17. Okay. Right now I already switched the cable from terminal 19 to terminal 17. So right now if we set 0%, let's see the milliamp is show 4 milliamp. Yes. If we set 50%, it will show 12 milliamp, right? Okay, 12 milliamp. 75%, 16 milliamp. 100%, it will show 20 milliamp, right? Okay, so correct. For calculation is correct. So we need to set the example from the HMI, right? So let me offline first and then go to create the text from the HMI. So anyway, this one we can rename as set value, example set value 1, and this one is output, right? So we can write analog out 1. Okay, so we can go to create the text. For the first one is MD24 for set value, and the second one is show the milliamp, right? So let's go to text, HMI text. Okay, so we can create the new text. Example set value 1. It is the real, right? So real and it is the connection. So MD 22, right, or 24? Let's check again. Okay, 20 MD 24. So we can select MD 24. Okay, and the second one we need to show the milliamp, right? So this one example raw analog raw one. It means that raw data of analog channel number 1, it is the integer, right? So it should be PQW 800. Yes. So we can go to our screen. Yes, go to our screen, root screen. Then we can create the set point and show the milliamp. So I will move the existing screen to here, and then we can copy. Yeah, actually we can copy. So we can copy. Yes. And then we can rename as set value. Okay, and then we can copy here. Actually this one we can comment as like this, from 0 to 100%, right? 0 to 100%. So this one should be a percent, right? The unit is percent. Yes. And for the output we can also show, and we can convert output, analog output, put value 4 to 20 milliamp, right? Okay, and then we can copy here. The unit should be a milliamp, right, for this one. Okay, we can align to be good looking. And then for this one is output, right? This one is input that we can write from 0 to 100%. So we can go to property. The first one we can select the text that we already created here. Set value, right? Okay, it is the real. and it is the input, right? So we can select input. Okay, so we can set, if we select input, we can set, and for this one is output, right? So the first we can select text, and then this one should be output. Okay, and for the text, we can go to the text and then go to edit, right? So here we can edit as the linear scaling. Example, the PLC show from 0 to 27,648. So the HMI will show 4 to 20 milliamp, right? Okay, so we can select like this, and then we can simulation. Wait a moment for simulation start. Not see any value, right? Because we are not yet online, so let me online. And then go to the, maybe we need to download again because we have some change for configuration. Then we can online. Okay, and then let's check the simulation again. Let's go to simulation again. Not see the value, right? So we cannot simulation with the module, right? So let's go to see the control panel, and then go to set the PC interface, and select the auto, yes, and then click OK, and then let simulation again. Okay, we have the value right now. Okay, so actually for the output we can also use this text. Example, I will change to the raw value to real also. Example, real, and MD28, right? MD28. Okay, and then go to the root screen, and we can edit the text again. Go to this one and go to edit again, and we can save, we can simulation. Okay, and then go to see the value. So right now we put 0%, So if I put example 25%, so the milliamp will show 8 milliamp, and the bitter is show 8 also. Let me show. Okay, right now 8 milliamp, the same as our screen. So if we put 50%, if we show 12, yeah, here 12 also, 75%, 16 milliamp, and 100%. If we show 20 milliamp, okay. So for channel number 2, we also do the same procedure, and we can simulation, yes. So this is just example about how to create the scaling for analog output, the same as the previous video also. In this concept, if everyone would like to use with the VFD set point as the percent, yeah, example 80% something like that, 80.5% something, it calculate also, okay. So this is just example about how to create, and everyone would like to apply to another project, so we can use this concept to modify, yes, or install a new project. So we can create the scale output for control the some electrical devices like actuator, VFD or something. So thank you very much for watching my video, and if everyone have any question, please kindly drop comment under my video. I will reply soon. And I would like to request all of you to like, share and subscribe my video also, to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again, and see you next videos. Bye bye.